a lot of stuff. Okay, so first things first. I first want to show you what's the difference. I want to give you my teacher glasses, bless you, and show you how to spot them. What do they look like? Because they don't come with the title like, hey, this is a rational function. How can you tell them apart? So let's do a real quick comparison between reciprocal versus rational. Okay. Rational is a fancy math word for fractions. So we're doing functions that are fractions. Okay. But excuse me, on Friday, we also did, they look like fractions. So how can you tell them apart? Okay, so here's what I'm going to show you. So kind of separate these two like this. Okay. All right, guys. So on Friday, we did reciprocal functions, and they look something like this. Okay. And you're like, well, that also is a fraction, right? So that must mean rational function. So let me show you a comparison. Let's say you had something like this. So what do you guys notice? I mean, they both have fractions, so how come they're not both? What do you notice visually speaking? What's the difference? There are no parentheses on that one, okay? Now, I'm going to show you something which you didn't know this, but what we'll do with these is we can factor them, and we'll actually need to factor them to extract the rest of the information. And sometimes they give them to us already factored, so they can look like this, for example. Okay, and now if they give them to us like that, then they both have parentheses, so that didn't help us. Okay, but I want to show you something that you do guys know already, right? Like if I asked you the movements, the transformations, I know everybody here could say, oh, that moves right 3, right? And this is from Friday. Remember, that's actually your vertical asymptote at x equals 3 for this type, for reciprocal. That one moves down 1, which is our horizontal asymptote at y equals 1. That negative is a flip, right? A reflection over the x-axis. And that 2 is a vertical stretch. I know you guys can know those because you do great when we ask you those. But over here, if I asked you, how does it move? What's the vertical asymptote, right? It doesn't tell us any of that. Does that make sense? Okay. And that's, I'm trying to show you my teacher glasses, how I can see right away what's the difference. These, I know the transformations. I know the movements. These, I don't. And look, even the movements don't make sense right here because, like, how could you move right 6 and left 1 at the same time? Right? It doesn't make sense. So that's the big difference. Does that make sense, guys, what I'm saying? Like difference-wise? Okay. So on this one, just to clarify even further, so we know the movements, right? We know the transformations. On this one, we don't. Okay, we don't. Okay. And so this is what the rest of today and the rest of these weeks, we're going to be focusing on rational, okay? Because we already did reciprocal on Friday. Now let me show you a visual, okay, of the graph. They also look different. So, okay, these, if you remember, we have our odd one, we have our even one. Again, this is from Friday, so if you're absent Friday, you might be a little confused, but you can catch up on those notes. Okay, so the odd ones look like this. The even ones look like that. Very basic, simple shapes. Okay, bless you. These rationals get really extravagant. Okay, some of the most fancy looking graphs. You could have horizontal asymptotes. You could have multiple vertical asymptotes, not just one. And they look a lot different. Like you have two, they're a little bit similar, but they have more going on. Okay, just more stuff going on. And so visually speaking, graphically speaking, they also look very different. Are we okay? Did it make sense so far? Okay. So I'm just going to split these videos up